To begin the course, please go into the Scenes folder and open up Gravity Experiment init. As you might tell from the name and how the scene looks, we're going to be performing the famous thought experiment of dropping two objects with a different mass in vacuum and see if they descend at the same time. By performing this experiment, we'll get a hands-on learning approach on what exactly are rigid bodies and how do they interact with the environment around them. Now, Unity uses NVIDIA's physics engine in order to calculate collisions. This is quite handy for us as we won't have to write code in order to go through every single one of the vertices in a mesh and see if they're colliding with a set of vertices from another mesh. Unity also provides us with a set of tools in order to make physics more CPU efficient, to reduce the CPU load. Instead of calculating everything from one vertex to another, it provides us with a set of primitives called colliders. Let's check out a few of them here in our list of ingredients: big rock, feather, small rock, and the ground. Now currently you can see that this is just a mesh filter, it has a mesh renderer, and it's got a material applied. If we go to component, physics, we see a list of different colliders. In this case, we just need to worry about these four: box, sphere, capsule, and mesh. Now, if I add, for example, box, Unity will automatically calculate the boundaries of the mesh. If we don't like them, we can move them around and resize them however we wish. Let's take a look at the other types of colliders. Component, physics, sphere collider. Pretty self-explanatory values. Positioning, radius, once again, fully adjustable. Capsule collider. Radius. And height. Now notice that there is no rotation parameter anywhere in this collider. The way that we adjust the positioning is through this drop-down menu. Lastly, the least efficient, but sometimes necessary, is the mesh collider. Uses the complete mesh of the game object that you're attaching it to. In this case, it's not that bad. This is a rather low poly rock, but you definitely want to use this as sparsely as possible. There's a couple more settings which are proprietary to the mesh collider. Convex implies collision between other mesh colliders. There's a limit on how many triangles you can have between these colliders, and that limit is 255 triangles. If you check and if you can pronounce smooth sphere collisions, it will smooth the normals, meaning that if you traverse a collider on top of this mesh collider, they will not have many rough edges. You might have noticed something else, and it's this reference variable that implies material. It might seem strange that a collider which does not have a renderer needs a material, and this is a specific type of material called a physics material. We will cover these soon. Let us use our new knowledge in order to apply a different type of collider to every single one of these objects in the scene. For this rock, I think I'm going to save the CPU power and apply a capsule collider. That looks good enough. Let's move on to the feather. Whoops. I'm going to apply a box collider. Now, this feather is going to be landing on this rock. I want it to eventually wrap around this object, so I'm going to apply a mesh collider. The ground will simply receive a box collider. As the scene is now, the colliders won't do anything. That's because in order to have active collisions, each one of the active bodies will need to have a rigid body attached. Let me show you what I mean. Both the rock and the feather are going to be landing on this small rock and the ground. This means that the objects that are active, feather and rock, need to have a rigid body. You can find this specific physics component in Component, Physics, Rigid Body. Now, we have mass in both of these objects, so let's just get the experiment out of the way now. Mass on the rock will be 100. These units, by the way, are not kilograms or pounds or anything else. They're just arbitrary unity units. I'm going to go into play mode by pressing Command P or Control P on Windows. And as you can see, while the mass is different, they fall at the same time. And also, as you might have noticed, the feather just completely fell through the floor. To troubleshoot this issue, let's check out the rest of the parameters of the rigid body component. What I'm pretty sure is happening is that the vertices aren't calculated between the feather hitting the ground, meaning that there's a small sample rate of time being calculated between both of the collisions. Now, Unity doesn't give us a sampling rate parameter per se, but it does give us this drop-down menu which adjusts several settings simultaneously. As we can see, the current method for collision detection is set to discrete, so there will be some aliasing to the amount of collisions taking place simultaneously. Continuous will of course also be aliased, but a lot less, meaning that the sampling rate is going to be higher. If we set this to continuous, what is going to happen is that this rigid body, this active rigid body, will collide with other components which are passive colliders, such as this rock, using continuous collision, while with other objects, such as other rigid bodies, it will use discrete collision. Now, if you are colliding with another mesh collider and you want to use continuous, both of these objects need to be set to continuous dynamic. For our purposes, I'm pretty sure continuous should be okay. Let's find out. This might not be the final effect that we want, but we will address that soon enough. However, you might want to drop both of these objects on, for example, Earth. So then the reason that the feather falls slower than the rock is because of air resistance. And this is where drag comes in. If we change this to, say, 2, we will see the feather slow down. It falls a little slower. Let's bump that up to 10. Okay, and that's a little bit more feather-like. This dancing around can be fixed as well. So guys, from what I can tell, it looks like there is some sort of seesaw effect. The feather lands on one of the sharp points of the rock and then just continuous wobbling from side to side, taking a very long time to settle. Now, we could remove this mesh collider, or simply disable it, and add something more round, such as a capsule collider. But we probably still will see some seesawing, because this is a rather long object, and while this rounds up, it might simply stick to the object. So we will need to reduce the friction, specifically on both of these objects. And this is where physics materials come in. Now, while you can create your own just by going create, this is actually out of the view of the screen capture, but there's an option that says physics material. But since we're still exploring this concept, we can import a few example files. Unity provides us with those in the Physics Materials Unity package. I'm going to import all of them. Going through each option, we see that the names kind of imply the parameters. Bounciness is a bouncy parameter. See, dynamic friction and static friction are all the same. The difference being is that dynamic affects moving objects, static affects standing objects, basically. This combine drop-downs simply takes both of the materials and asks you, what do you want to do with them? Do you want to multiply these values? Take the smallest? Take the average? Or take the biggest value out of the two objects? We're going to use one of these presets and apply them on both the rock and the feather. Let's see how that works out. Actually, considering this is a very thin object, we might have issues of this falling through the ground again. So this is a good opportunity to use another material. Let's drop in rubber onto the ground. Let the games begin. Okay, it's flowing nicely. A little seesaw, but much better. Okay. For a feather effect, I think this is enough, but if you wanted one object to completely wrap out another, Unity does provide a solution that's okay, and those are soft bodies, also known as cloth.